All right, so for the first one, this is our foldable, or at least the notes that are going in the foldable. So if you just type this up or write this out, this will count. If you're doing it in a foldable form, what you're going to do is take a blank sheet of paper, fold it in half, and cut one end of it. So you have one side that has 3 flaps. So you're going to cut into 3 flaps. And then that way when you open it, you have your definitions here, your examples on this side. We're doing it on this paper right now because it's attached to the What is Heat reading that's in Schoology under the date for December 10th and 11th. I did not go over this on camera because the answers can be located in the reading and can be done independently and submitted through Schoology. So the first one that we're going to write is conduction. And if you looked in the reading, that it's that first paragraph that talks about conduction. What does it say conduction is? Heat transfer through, raising your hand. Heat transfer through, Bo, direct contact. So on this side, because it says heat transfer using, we're going to write touching / direct contact. And I have a way to help you remember this. The D in direct and the the D in conduction and the C in conduction stands for direct contact. You got to find a way to remember. And I've noticed that as we go through the year, a lot of students are finding their own tricks. So eventually, when you don't have me as a teacher, you guys can use this as a resource. So it's heat transfer using touching or direct contact. The D stands for direct and the C stands for contact. So let's think about examples here. What are some examples? There were some in the reading. There are some that we can think of. Carly? Yeah, I'm going to say anytime you burn yourself, right? If you burn yourself, it's because you touched something hot. When you drink hot cocoa and you're like, oh, my tongue, right? That's considered conduction because your tongue touched hot liquid, right? So I'm just going to say burning yourself on something hot. How many of you have ever gotten in the car, right? It's a hot sunny day. You've gotten in the car. And you burn yourself on the metal seatbelt. Yeah. The seatbelt was heated through radiation rays from the sun, but then you touching the seatbelt and burning yourself, that was conduction. Give us one, go ahead and copy that down for me. Give me another example, one of my mobile friends. Give me an example of conduction. When heat is transferred by touching. Venetia?
Is it like when something is hot and then like you touch it like um
Think about when you cook or when you see your parents cook. What
I
would be
don't
an example? Go
oh
ahead,
I know
honey.
like when I have my heater under my glass table, when I touch the table it's hot.
Okay. I'm going to talk about space heaters in a second. Let's think of another one. Cedric. Can, go ahead, Cedric. You're You're frozen, baby. Go ahead, Antoine.
Okay, there you go.
A stove or a
Yeah, so
oven.
if I have well, an oven is something different, but let's think. If I have a stove,
Really? Can you hear me?
I can hear you now.
Oh, can I show my example or?
Yeah, go ahead.
So I don't know if this is, but like when your phone overheats and you touch it and it's like hot.
Okay, so but there we go. Like touching something that's hot, right? When you burn yourself or you touch something that's hot. If a pan is touching a stove, that's how your pan cooks your food, right? At the same time, the food inside the pan gets cooked because it's touching. You should be writing. So the food is touching the pan. Those are our examples. Cooking or baking in a metal pan because the metal pan heats up. Well, we've got to move on. We're falling behind. So I'm going to hold it for right now. And you can give me an example for the next one. All right, so our next one that we're going to talk about is convection. Now, this one is a little tricky because this one is heat transfer through liquid or gas. And it uses currents. Currents are when hot air rises and cold air sinks. So the V is like a down arrow. If you guys have ever seen a hot air balloon or heard of a hot air balloon, the hot air balloon goes up when there's a fire in it, right? But when I take the fire out, what happens? It goes back down, right? And it kind of deflates a little bit, actually. So a hot air balloon, and there's that word air, right? Here's another one. I got one of these from a family member, and I absolutely love it. An air fryer. An air fryer is cooking, look, and it's moving through gas. It's moving through air. When I boil water, this is probably the most famous one. Remember, the bottom of the pan is the bottom of the pot is touching the stove, so that's conduction. But inside, the water's not touching the stove. The water gets heated by the pot. The hot water molecules rise. What happens when the hot water molecules get to the top of the surface, Bo? Okay, before the steam, what do you see in the water? Bubbles, right? Then the bubbles pop. Bubbles pop. Then when they pop, they release steam. Steam is hot air rising, y'all. Once that hot air is released, it's cold again. Or not that hot water is released, because remember, steam is just water vapor. Once that hot water is released as steam, it gets cold again and sinks back down. It creates a little current. That's why it keeps bubbling. All that water keeps sinking back down to the bottom after it pops because it's cold again. It said thunderstorms. Thunderstorms can be an example because that's when the warm air rises, the cold air sinks. You'll notice in this school, the downstairs is colder than the upstairs because hot air rises. Your attic is probably the hottest place in your entire house. And the basement's the coldest. The C also stands for currents. And we're going to keep practicing this. And I've got some visuals for you that we're going to go over after break. Mark? Yeah, water. Well, no, if it's heated by the sun, that's something else. Only when it has a current. You can think about it like this. You know what? When you go in a pool and you dip your foot in the top of the pool and it's warm and you're like, I'm going to jump in. That water seems warm. And then you jump in and you go deep and the water's cold. The fact that the warm water is at the top, it's like that because of convection and the cold water sinks. All right, last one, radiation. The R stands for rays, like the sun's rays. So this is using electromagnetic waves. No touchy. So using electromagnetic waves / rays. No touchy. So we already said the sun is an example. What's another one? Give me another example of radiation, ways that I would feel heat without touching it. Think about the reading we just did. Antoine?
I was going to say microwave.
A microwave, it uses the word wave, right? Nothing in the microwave, if I was to stick my hand in the microwave, it's not hot, right? But once I turn it on, it's actually emitting waves, electromagnetic waves that heat your food up. That's perfect. Ovens, the heat comes from the top and the bottom, right? In an oven. Is my food touching the top of the oven? Is it touching the bottom of the oven? No, it's kind of in the middle, right? And then it sends heat waves. Now, especially if I'm using a glass pan, and you'll see that when we watch the Bill Nye, the waves move through the glass, cooking everything evenly. If you cook in a metal pan, your food's going to be crispier because the metal itself is also conducting heat because the metal pan is hot and it's touching the food, right? I cook with cast iron, that's almost exclusively. So cast iron is a conductor. It gets hot. So when I cook in cast iron, like I like to make cornbread in cast iron, and the edges of the cornbread gets real crispy. But if I were to cook that in a glass pan, the edges wouldn't be very crispy because it would all be cooked evenly because the waves are moving through the glass. So cooking in an oven, especially with a glass pan, because the radiation, the waves move straight through the glass. What's the one that we read about in the fire? I just said it. What was it? Fire. I do that all the time. Got to slow my brain down a little bit. I meant to say which one was the one in the reading with Paul and his dad, but I said which one was the one in the fire? And we're going to keep going through this. I've got some examples that we're going to do after break. We're going to play, we can use some of these examples in our Kahoots that we make on Tuesday. You guys are going to build your solar ovens, and we'll talk about how each one of these is used when we build the solar ovens. But if you use these tricks I showed you, conduction is direct contact, so touching. Convection is using currents. Think about the V as an arrow, right? Cold air sinking, hot air rising. And radiation is rays like the sun. I'm not touching the sun, right? But I still feel its warmth. Everybody follow me there? All right.